So we had this idea that 1 radian was when the arc length is exactly the same as the radius. We talked about circumference being 2 pi r. So since there are 2 pi radiuses around the circle, that means that there are 2 pi radians in a circle. And we were just in the process of trying to find out what 1 radian was exactly in degrees. We estimated it by saying that when I have an equilateral triangle, the angle is 60 degrees. When I push down on my equilateral triangle to make the one side bend like a circle, that angle here will change to be a little bit less than 60 degrees. So we were in the process of figuring out that what a radian was exactly. We had talked about circumference being pi diameters around the edge and how you could use string to measure that. And then I was just in the process of getting off topic about how, well, not off topic, but on topic, off topic, about how it was that Archimedes, one of the first greatest mathematicians of all time, how he estimated what pi was, and I was going to talk to you about his method of exhaustion. Do you remember that? And then you guys got called down for pictures or something. So, what Archimedes started with is he said, if I draw a hexagon inside a triangle, and he had the skills to be able to do that directly, if the radius was 1, then the distance around with the hexagon, and you don't have to write this down, just a story, you can just watch. If the radius is 1, and these are all equilateral triangles, does it make sense that the distance around would be 6? And so he knew that the circumference was more than 6. He also had the skills at each of these points on the edge of his circle to draw tangent lines. And if you draw tangent lines at each of those, you make another hexagon on the outside. Can you see the hexagon on the outside? And he was able to, using the math that he had right now, he could find out that distance perfectly. And I don't know what it is. Let's just estimate it to be 6.5. So he was able to say that I know the circumference in green is somewhere between 6 and 6.5. Fair enough? He then said, well, I have the skills that I can split each of these in half. Oops, not that one. This one, this one, and this one. And if I split each of those in half and make new points where I connect that point through the center to the edge of my circle, and I now connect points on the outside to those, I make a 12-sided shape, a duodecagon. And he was able to calculate the perimeter of that duodecagon. And all of a sudden, his distance around became 6.1. He also then drew tangent lines at these points. And drawing tangent lines at those points made a duodecagon around the outside. And he was able to say the distance around that is a little bit less now. He split it in half again and did 24. He split it in half again and did 48. He split it in half again and did 96 and did all the calculations needed to calculate that. Have you ever seen a 96-sided polygon? A 96-sided polygon. Let me see if I have some. So he got really close to pi being 3.14 because the 96gon is practically a circle. That he said if I kept going, I could get as close as I wanted to pi. And then he started making fractions and saying, like, I think these are the fractions he used. He said the number we're looking for is somewhere between 22 over 7 and 335 over 113. Let's try that number.
How do you figure out these numbers?
How do they know?
No, it wasn't 300, maybe 355. See if that's better. See, I'm not remembering the numbers. I know I should work on that, eh? That's better. 355.
How do they determine pi?
This is how they determine pi. By going close. This is the first person that was able to determine pi as close as they wanted. Because at his decimals here for an approximation,
How do they create it?
okay, this one is 22 divided by 7 is, oh, I've got them in the wrong order. Less than or equal to pi, less than or equal to 22 over 7. This one is 3.14159, and this one he got is 3.1428. And what's pi? 3.1415926. And this one is 929. So he's very close.
So is it like the mathematicians?
So he was able to get to pi as close as he wanted from this. And so from there, we can now say that there's this number. And this number is calculated by, you could keep going further and further with how many diameters and figure out the pattern and figure out the math. Because figuring out perimeters of hexagons and duodecagons is mathematically possible. Figuring out the perimeter of something that's round is not easy to measure. Okay? But then using that, we now have this idea of pi. And since then, there have been other calculations that have been used to get closer and closer to pi. Yes? Yes. You ready to learn? There are 2 pi radians in a circle, which means that 2 pi radians is equal to how many degrees? 360 degrees. So if I know that 2 pi radians is equal to 360 degrees, could I figure out how much 1 radian is? How would I do that? Divide by 2 pi. So we go to our calculator, we do 360 divided by 2 pi. We're careful when we do that so we don't get a wrong answer. So make sure that you are able to get 57.295 or 57.3 degrees. That's an approximation, so we should change this sign to an approximation. If we wanted to get the exact value, 1 radian is equal to 360 degrees divided by 2 pi. Could I reduce that? Yes, I could. 180 over pi. Does that make sense?
Yes.
Okay. If 2 pi radians is 360 degrees, would it make sense that pi radians is 180 degrees? Could you figure out what 1 degree is equal to in radians? So you could take this. I really like using this a lot. Pi radians is equal to 180 degrees. So if I wanted to find out 1 degree, what would I have to do to this side? Divide by 180. So 1 degree is equal to pi over 180 radians. That is a good question. So here on this side, to get 1 degree, I'd have to divide by 180?
What is the one at 7? You just still divide 7 by 180 then?
Well, once I have 1, okay, this is a good question. It said, what if she wants to find 7 degrees in radians? What would you have to do to 1 degree? What would you multiply to get 7 degrees? 7, right? So what would I have to multiply this by? Okay. The other question that was asked, I heard in the back there, is there a symbol for radians? Because I'm getting tired of writing out the word radians. Good mathematician doesn't want to write more than you have to. Shouldn't there be a symbol for it? The answer is no. There is no symbol. In fact, that means if I draw a triangle and I label this as 1, that means 1 radian because no symbol was added. And so if that means 1 radian, if you wanted 40 degrees and you wrote it like this, you lose a half mark because you just wrote 40 radians. Because you didn't include the degree sign, it means radians. So when no symbol is added, it means radians, which is significant because 40 degrees, this looks like at about a 40-degree angle, okay? 40 radians, 6.2 radians is 1 turn around the circle. 2 pi, 6.28 approximately, is 360 degrees. If you wrote 40 radians, that's like 6 and a bit turns around. That'd be like over 2,000 degrees. That would be a bad mistake.
So when you're asked to like solve something for radians,
You don't have to write the word, you just write the answer, and it assumes you're talking about an angle with no symbol. It assumes that it's radians. So on your next page, well, on the first page, you have your definition of radian if you would like to highlight. A central angle with the measure 1 radian is subtended by length of r. That means when the arc is r, you have 1 radian. Okay? And, oops, must be at the bottom here. On your next page, you have some important formulas. This is the starting one. If you know that there is 360 degrees in your whole circle, you can know that there's 2 pi radians in a whole circle. That's based on your circumference. And that becomes your starting point. If I know there's 2 pi radians is 360 degrees, I can easily divide both of those by 2 to find out this fact. Now, one of the things you're going to develop in your language is sometimes when we talk about things, we take out words. Okay? Sometimes this semester you're going to talk about pi radians is equal to 180 degrees. But you're going to say to your friend, oh, and since pi is 180, da-da-da-da-da-da. You're going to take out words, okay? Pi is still equal to well, not equal. Pi is still approximately 3.14. 3.14 radians is approximately 180 degrees. Pi radians equals 180 degrees, but pi never equals 180. Does that make sense? No? Does 1 equal 12? I'll trade you $1 for $12 if they're equal, right? But where is 1 equal to 12? Does it ever happen in real life that 1 is equal to 12? 1 dozen is equal to 12 eggs, okay? 1 foot is equal to 12 inches. So 1 is equal to 12 in some situations, right? But not in all situations. You need units there to make them equal, right? 100 is equal to 1. When does that happen? Meter and centimeters, dollars and cents. So we have different places where numbers that aren't equal are equal to each other if we include the units. Pi does not equal 180, but pi radians equals 180 degrees. Okay? But some of you will say, well, isn't pi 180? No. But I'll know what you mean, but you're just not using all the words. Okay? And then from these formulas, we could get 1 radian by itself and 1 degree by itself. And those formulas are hard to memorize if you just try to memorize them directly. Can you see that they're hard to memorize? Because they're so similar. One is pi over 180. One is 180 over pi. So if you try to memorize those, because they're not on your formula sheet, you will make mistakes and screw up royally because they're so similar. Those are not on your formula sheet. However, if you use the blue one, to go to here, what would you have to do to get from pi to 1? You'd have to divide by pi, and then this one makes sense. If you go from this one to this one, what would I have to do to get to 1 degree? I'd have to divide by 180, and that one makes sense. So if you start with the blue and the green, you can create the other ones. And then that will help you remember them. No, you need to know all those. The only formula on your formula sheet so far, okay, so far in this unit, we learned our arc length formula in degrees. So off to the side, you have a little bit of space here, right? Okay. Off to the side, we're going to write down that formula again, arc length in degrees. And the textbook uses S for arc length, so we'll use S as well. Remember, it was a percentage of the whole circle, theta over 360 degrees, of the whole circumference, 2 pi r. Right underneath it, we're going to write our arc length formula in radians. So now my angle theta is going to be in radians. But the idea is the same. So instead of writing theta over 360, I would write theta over, instead of theta over 360 degrees, it'll be theta over 2 pi. And then here's your whole circumference. And this one, mathematicians just cannot resist simplifying it. Do you see how nicely this one simplifies? The 2 pi on the bottom, and then you multiply by 2 pi. And the formula is just theta r. And that formula is on your formula sheet. The easiest looking one. Okay? But this formula we developed as an idea. So if you have the idea in your head, you will never forget that formula. And if you have the idea in your head, you could do it in radians, and then you'll never forget this formula either.